Hi, my name is Frank. I'm from MapLibre, and we have developed over the past year a new tile format which we are excited to share. So, how came this format to be? Well, frankly, academia showed us that there is there is a lots of space to go if we want to be more performant, and enterprises funded this work because, well, engineering takes money to fund, and then it became a success in the open source world. But let's back off a bit. So, story time. Where am I coming from? I'm coming from Munich. What's Munich known for? Huh? Beer. Nah, not really. We are known for building very high performance databases and these sort of things. We have a really nice research arm there. So, what databases do roughly exist? Two kind of systems. There are the analytical systems, which you then let crunch over your entirety of your data over the last 5 years. And then there are the transactional systems. Transactional systems are things like, hey, do I have in my shopping cart, or things like that. Okay, so where do modern maps like Mapbox or MapLibre fall into this in terms of the data that we consume? Huh? What do you think? It's transactional because the data that exists can be very easily editable, and I can edit only one field. We think if we flip this around and then compress this down, because frankly, if I have a series of numbers that are all numbers, I can compress them more effectively than as if I have a number, a string, a number, a string. Things like that. And that's what MapLibre tile format is. Yeah, so why the new tile format? Well, we didn't like the name. No, not really. We can do much better with 3 times better compression and 3 times better decoding performance, and we are doing this via this switch that I've just talked about, that we're turning it around and doing it column oriented instead of row oriented. So we can also add new features like M values, more different kinds of geometry, different kinds of things we put in there, because currently MVTs are very limited in terms of what they do. And we can also pre-tessellate the tiles. Why am I talking about tessellation? Because tessellation is one of the things where we spend most of our time in rendering, which like at least for our use case, that's tremendously wasteful. It bloats the tiles by about 20%, but then you spend much less time rendering. So it's worth it. So now I've given you the global picture. Let's dive deeper. So, and let's also give more context. When you do modern maps, some of you might know these raster or satellite views where you stitch together multiple PNGs. On the vector front, that works by having geometries packed into tiles and then sent to the client. And the client then can decide how to display them. So we do this in a tile pyramid. So above and at the global level, there are very few extent, but then you need to simplify it a lot, and then goes down in a quad tree manner. Yeah, and in each of these, there's then the geometry aspects and the metadata of that geometry for a tile, and it works out. So let's dive into MVT a bit. because without knowing what MVT is, it doesn't make sense to talk about what a new format we're building. So MVTs is a big tile. Oh fuck. It is encoded in a protobuf, and this protobuf contains multiple layers. Okay. Each of these layers then contain different things. For example, they all contain a metadata, they all contain a key dictionary, a value dictionary, and the actual geometry features themselves. The key dictionary and value dictionary are just for making for not having multiple times the name field, for example, if you have multiple keys, and it's a bit more efficient this way. But yeah, I've just talked. It's a bit more efficient. Like where is this actually suboptimal? Well, first of all, these features are inherently very hard to render. Like Mapbox can sing a song on that, likely. And this, frankly, this is like shooting yourself in the foot a bit, and then complaining that you shot yourself in the foot. So that's one of the problems. And also this key and value interning. We're still shipping all that duplicate data. It's not very efficient. So we can make this a lot smaller and a lot faster to render. So TLDR, why did Mapbox back in the days decide to do it this way? Well, frankly, back in the day, back in 2012, we wanted to get something out the door. Well, now, 10 years later, roughly, we want to make it fast. And that's why we're doing it. So let's now build on the stack of ideas that I've roughly talked about and go get to what MapLibre tile format is. So we start with a smaller tile. We cut it up into layers. That is reasonable. First change. We put a size and a tag in there. Why size and a tag? Because then I can efficiently skip each of these layers. For example, if I know that my client won't decode a tag. Tag is basically a version number because we don't think we're gonna get this right on the first run. There will be new encoding improvements, and we want to make this future-proof, so this tag is currently 0x1, but that will likely we will need to make future improvements to that, so that's the mechanism for adding new things to the spec. And then there's the data. So let's dive a bit into one of these layers and talk a bit about encodings. You likely all know gzip and zstandard, these heavyweight encodings, but those don't work for us. They don't work for us because they are very heavy in terms of how much compute I need to do to get one bit out of them. They are very cumbersome, very large, even though they are currently mostly put into browsers, so therefore not such a big problem, but the amount of compute I need to get out of them is still immense. And also we can do a lot, like if you use more lightweight encodings, then we can get more out of it. And so here's, for example, how BetterBlocks does this. This is like a Parquet replacement, also from Munich. They split each of the value types up into all of these different things. For example, strings get FSST or dictionary FSST encoding and such. So if we specialize them into where these encodings are best, we can get lots faster performance. And here are the encodings that we have. We have a plain encoding, we have a Boolean run length encoding, which means that now instead of sending all of these Booleans over the wire, I'm sending you, hey, 20 times true, and you know to decode them as 20 times true. Also, delta and RLE also fairly simple to do. Delta, I'm just sending you the delta between the first one, and I can squish them down because the entropy gets lower. And rung length encoding is also for duplicate values in a row, which is fairly common in tiles. There are a few more complicated encodings in here, which have come from decades of research in databases. For example, FSST comes from Munich, the ALP comes from Amsterdam, from the DuckDB guys, and I think we also have we have FOSS4G in there, which is from the Quebec database guys. Database guy, more rather. So that we were building on a decade of research here. That's why we are faster. It's not that we are much smarter, it's that we are actually building on the newer tech. If you want to know more in depth about the reasoning why we chose these encodings specifically, Marcus has a talk on that. He talked on that in the last State of the Map and the FOSS4G conference in Europe a year ago. We have slightly shifted a few things around, but it's mostly still the same. For the people who are in academia, there's a paper on that. It's a fairly short paper, only 4 pages, I think. So not the most detail, but it is a paper, and it's published at SIG Spatial, I think. So it's also at a reputable conference. So I think we have done good work on this. And yeah, for the people who are into specs, we also have a spec online. We are not an OGC spec because we don't want to cough up the 30K for that it takes to be an OGC spec. But like, we are an open spec. Yeah. So yeah, sorry, it's just kind of expensive to be an OGC spec. So we at some point we might be a community standard, which I think is much more reasonable in terms of what pricing looks like. So, yeah. And yeah. So let's get to software support. Which software supports it? Well, it depends. Our renderers do, but well, only if you're really living on the edge and creating your own tiles, because frankly, only Planet Tilers currently supports this. But later this year, we will be likely in much more offerings, like for example from Stadia Maps or things, the other tile providers. And AWS is going to fund a few improvements in this area for some tooling, which is gonna be nice. Now to the offboarding part. So how to get in touch with us? Well, we have GitHub discussions on our issues. We have our issues. We have a Slack where you can talk to us at maplibre.com/community. There's also a map where we show who's like in our community. You can join our community. And we have technical steering council meetings every second Wednesday, I think. Yeah, no, that's great. We have a monthly newsletter which we are sending out either on LinkedIn or our website. You can join, subscribe to the RSS feed, and yeah. So let's recap. What are we? We are much smaller. We are much faster. We are doing this via lightweight compression, which previously has only been used in databases. And this might unlock much more features, which is going to be nice. Great. It's a great time to be alive. So, questions? So, Mapbox. Sorry for outing you.
Does it mean it times faster? Or does it load 3 times faster by 3x better? Do the tiles load and render 3 times faster?
Yeah, well, the decoding performance is directly the speed at which you that's the direct speed. And obviously, if it's 3 times smaller, assuming you have like not magic internet, it also that's also smaller. So in reality, it's actually more than 3 times, but that depends on your internet. How what the end-to-end latency is, because if your internet is a German internet quality, and it's gonna be a lot more than if it's I don't know. India has good internet, right? Yeah, I'm seeing some nodding. It's not as shit as our horrible backbone. Yeah. So you will also get nice speed ups there.
Thank you. Is there examples online? Hello? Yeah. Is there examples online where one can see the difference comparison side by side and just feel it?
I don't think that currently exists, but would be a nice gimmick to do. Yeah, we should do that.
Yeah, thank you.
Hello.
Hi.
If I want to generate MLT tile, how I can generate?
By a planet tiler. Very
Yes.
simple. You pass the planet tiler has a flag for that, where you can specify. Currently, it's defaulting to MVT, and if you set the planet tiler flag to MLT, and you're generating MLTs. And yeah, we also have a conversion utility, but in the end, using planet tiler is much more convenient. Let's be honest.
Okay, so I need to use Planet Error.
Well, currently yes, or use our conversion utility.
Yeah. Okay.
To convert your MB tiles to MB tiles containing MLTs.
Yeah.
Which also works.
And best luck. We will see in OGC standard.
OGC standard is not currently planned because that's quite expensive. Community standard is much more reasonable. I'm sorry. Mapbox is not an OGC standard.
Yeah, and yeah, so I have a question. So I know a little bit of your background. You are a developer, so may I ask, how is it having a better compression ratio? Like how, what is because of what features it is having better compression ratio?
So what features allow us to have better compression ratio? We tried to make it in every department. So if you want to make a competitive thing where the competition cannot just say, oh yeah, but look, I'm encoding booleans, and then you're suddenly shit on booleans, and you need to do better in all of these values, and that's how we can achieve 3x smaller tiles, which is reasonably hard because Mapbox did a good job at that one. That was good engineering, but I think if we add lightweight compression, that's in every department we can get much better. It really depends what data you're encoding. I'm sorry, it's like most things in software where the answer is not, it's because of we used magic here. It's because the it has solid engineering behind it. It was a lot of work. That's why it's better.
Any other questions do we have? Yeah. Thank you, Frank.